So we are here today with a new webinar offered by GMI International. Since a couple of years, we are delivering online webinar on different topics. So we touch functional safety topics, we touch intrinsically safe topic, or we touch also application topic using our specific components or modules. Today we are dealing with functional safety, and today we are touching a very specific topic. I'm not going to enter into detail because I would leave to Tino the possibility to enter and discuss in detail. Just give me a few minutes, not more, to give you a short introduction about myself and Tino and about GMI before to come to the specific topic. So we are here today with Tino. Tino is our functional safety director. I'm working with Tino since almost 25 years. We started in another company and today we are together here at GMI. I am Mauro Perego from GMI, of course. I'm Global Sales Director. Just a short view about what GMI is doing. GMI is providing a field interface to the market. And I'm talking about field interface dealing with the two aspects of safety. One, it is functional safety, and the other is intrinsic safety. So our product either are seal suitable or intrinsic safe. You find our components and solution in different automation package like TCS, ESD, in different industrial sector like oil and gas, petrochemical, pharmaceutical, food and beverage, for example. GMI has 40 years of experience in the field, and it's a company with 100% production here in Italy. But of course, we are present worldwide in different continents, in almost all continents. We have several subsidiaries, we have partners. We are a relatively small company, but I would say very efficient. And since we are talking about functional safety, it is also good to mention that we are delivering almost even during the COVID period, we have been able to deliver to the market functional safety training or cybersecurity training. Today, most of them are online, but slowly we are moving to the face-to-face trainings. So you will have maybe the chance, or some of you already had the chance to participate to such training. But I leave later on some space to Tino to mention that and to enter a little bit more in details. Okay, since we are dealing with safety, meaning health of people, environment, and assets of company, the quality of our product is of the utmost importance. So everything is done here in Italy, and everything is full tested before components are delivered to the market. We are so confident about the quality of our product that we deliver with 5 years warranty. As said, we are an Italian company, but dealing with a lot of other countries, and of course, in addition to the quality certification that are demanded by the market and are necessary to fulfill the requirements of our customers, we have also almost all certificates which allow our product to be used worldwide. So you see here in this page a lot of symbols which represent the local certification which we are covering with our product. Just for your information, at the end of this webinar, you will receive a copy of this presentation. And you will also have the chance, if you miss any point or you want to review part of the presentation, you will see this presentation available on GMI YouTube channel. Okay, this is a short view of the product we are delivering to the market. We are talking about intrinsic safe barrier, safety relays, isolator. We have power supply systems as well as multiplexer. And of course, our modules we can find tailored solution for the different PLC system. That's why we have a specific dedicated termination board to almost all main system in the market, DCS, ESD, or PLC systems. We have hard multiplexer solutions, surge protectors, and loop indicators for field indication. Last, it is not a product itself, it's not hardware, but it is a service that we provide to the market. I'm talking about functional safety courses, cybersecurity training, as well as consultants, which when we talk about functional safety, they are executed together with Tino. So if you are interested, we can also have a deeper discussion on that. You will see at the end of the presentation the email address from myself and Tino. If you need any further information, whatever it is, depending whether it is on the company or whether it is on the topic we are touching, you can drop us an email, and we try to give you any answer to clarify the topic. Here it is just a list of typical customer we have. Of course, it is not extensive, it is just an indication. And well, as promised, I have been short because I want to leave the discussion and the presentation and the speech to Tino, because today we are touching a very interesting topic. It is a very specific topic dealing with the architecture of which are demanded and topics that you have to face when you are defining an architecture with your SIF. And so I leave the speech to Tino, because I'm sure he is more efficient and he can provide much more and deeper information about the topic. So Tino, I leave the speech to you.
Okay, thank you, Mauro. Thank you for GM International for giving us another opportunity to provide a webinar. Can you release the control, Mauro?
Yes, of course.
All right, one more housekeeping topic. If participants have a question, you can fill it into the Q&A box, question and answer. We will answer, of course, if we have the time for it. Mauro will monitor the Q&A. Chat box is not to be used, so it's only the Q&A. And at the end of the presentation, we also collected during the pre-registration, we collected some questions, and I took the liberty to take the, let's say, the more interesting questions out of it, and I already prepared some answers, which we also will provide at the end of this webinar. And during the webinar, there will be some poll questions, that just to get some interactions from the people who are following it, to see that there is some understanding of the topics we are providing. Let me jump into the topic for today. As Mauro was mentioning, it's called the minimum architectural constraints from both standards, 61508 and 61511. Purpose of this webinar was to give or is still today, to give a overview, what are the similarities or what are the differences between the two standards when it comes to the architecture of your safety loops, of your safety instrumented functions. The one that I have here in front of me, the life cycle that you are looking at now, is the one from the 61508. So the topic that I selected for today will be handling somewhere around here, coming from the safety requirement specifications into the real design from both the hardware and from the software from a device. So when you hear the 61508, It's clearly the standard which is handling the EEPES systems, standing for electrical, electronical, programmable, electronical safety related systems, which is the standard that the manufacturers such as GM International is using to prove the compliance to the standard of functional safety. What is hardware safety integrity architectural constraints? As we call it, typically the hardware architectural constraint. Well, we typically will abbreviate that with a term called HFT, and HFT stands for the hardware fault tolerance. And the high safety integrity level, or the high SIL level that you can achieve of any safety function will be limited to the hardware safety integrity constraint expressed as an HFT. And you will see that based on the newer editions of the standards, and the newest edition from the 61508 is still edition 2 today. Edition 3 is coming, but it's not released yet. So we're still working with the edition number 2, which was released in 2010 in April. And HFT, if you want to express this very simple, you have to ask yourself the questions: how many danger failures can your safety loop tolerate and still achieve your safety function? So HFT is an expression in a number. So we will see HFT equal to 0. That means that type of architecture cannot tolerate any danger failure. If you see HFT equal to 1, that means at least that architecture of that safety loop will be redundant. That means that one of the two redundant partners can actually have a danger failure, and you can still achieve the safety function with this type of configuration. The minimum HFT, as per the 61508 standard, can be achieved now in 2 different roads, and we call this road 1H, which we show here on the last bullet, road 1H, or we can use road 2H. But that means totally different items according to the standard. And I find out that people typically, they will jump on one of the road selections without knowing what are the preconditions to fulfill before they are allowed to choose this road 1H or road 2H. And the purpose of this webinar here today is to try to give you some indication and summary that you will know at the end of the day what road was meant to be used for your selection of your architecture of your safety loops. In the title here, between the brackets 7.4.4, for those who are more the specialists and the experts listening here to this webinar, that is actually referring to the part, which is here part number 2 of the 61508, which is indeed the hardware section of the 61508 standard of 2010 release. And if you would go to item 7.4.4, there you will see that the hardware safety integrity architectural constraint is explained in 2 roads. Road 1H will be based on a hardware fault tolerance table, which we call the HFT table, together with the safe failure fraction, which we call the SFF. And the safe failure fraction is a percentage of a quantity of how many danger undetected failures are hidden away in your architecture or in your subsystems. That is the concept known since 1997 edition 1, because edition 1 of the 61508 was using only that road, and only that solution was the way that you could have been chosen if you are selecting your subsystems. And in 1997, we used to call this type A or type B tables, which is still today called table 2 and table 3. And table 2 will be for any type A type of subsystem, and table 3 will be for any type B of subsystem. Road 2H is based on component reliability data feedback from end users. That means that road 2H is actually the feedback that the manufacturers have been collecting from install base from their end users, and that is called proven in use. So when you hear the word proven in use came into question in 2010, or actually has been released or defined in 2010 in the 61508 standard. And the proven in use is actually from an increased confidence level where they will actually show, based on two standards, how the manufacturers have to collect their field feedback from the install base, and based on that table you can claim road to H. But I got a summary later on with a table that I can show you more details of. The table 2 and table 3 are type A and type B of a subsystem, and that is a table that is already existing since 1997-1998, which is the first edition of the standard. The safe failure fraction here on the left column will be deciding what is the minimum hardware fault tolerance based on the type selection. So how do I use this table? First of all, I have to find out from the manufacturer what type A or type B, the subsystem have been decided for. That means that if you have a type A subsystem and they have been giving you a safe failure fraction, which is typically a indicator in percentage that will be either it will be defined or it will be mentioned in your certification papers. So if they have made a assessment on the system and that this was leading into a certificate that will also mention it was a type A or a type B system, plus also they may have given you the safe failure fraction on that. If not, it will be definitely in your safety manual of your compliant device if it is a 61508 compliant subsystem that you are using in your safety loops. So once you know the safe failure fraction, then you have to ask yourself the question, what is the target of my SIL level? Assume that we are buying a safe failure fraction subsystem, and a safe failure fraction is somewhere between 60 to 90%. So you are here in the second row, and your target would be a SIL 3. If you look up, you see here an HFT equal to 1. That means that you will use, or you will have to use, two of those subsystems sitting in the range of 60 to 90% before you can claim that your loop is in compliance to a SIL 3. That is how we're going to use this table A, same for this table B. When I compare that to the 61511, there we have simplified the way that we're going to build our safety loops or our safety instrumented functions or our SIFs. And here we are looking mainly here between phase number 3, which is the safety requirement specification. It is the first time that somehow in some safety requirement specification you may notice what is the HFT or hardware fault tolerance that the people want you to use, or that the engineering departments want you to use. It will certainly be important that once you are here in your design and engineering of your safety instrumented system, how do I build my system? I give you two examples. If you have a requirement coming out and saying we want to build a SIL 3 loop, but we do not know yet what type of subsystems or what type of equipment we're going to find on the market, well, then the HFT will be decided here in your phase number 4, because there intentionally you will try to achieve a SIL 3 compliant design. That means then you will have to decide how many of those subsystems will I have to use in able to comply to the SIL X requirements. So if I go more into detail, here again we have this road 1H and this road 2H, but in the 61511 edition 2, which is 2016-2017, if there would be someone from the US region, which I doubt because of the early morning session here in Europe, but if there would be someone here referring to the ISA 61511, then it is a 2018 release back in the USA. It's still the same reference. It's still 11.4.3, which is from the normative section part 1 from the 61511 edition 2. There also we are calling it the hardware safety integrity architectural constraint, and there we have the same expression called HFT. But here the SIS, or the safety instrumented system, shall have a minimum HFT with respect to each safety instrument function it will implement. And when you can actually split your safety instrumented system into independent subsystems, example giving like your sensors, your barriers, your isolators, your safety relays, your logic solver, final elements, etc., well, then your minimum hardware fault tolerance can be assigned to every single independent subsystem level. But the 61511 edition 2 approach was different than what we were doing in the 61508 edition 2, because the edition 2 of the 61511 prefers as a preference the prior use. And mind you here, we're not calling it proven use, we call it prior use. So there's a difference. We distinguish between prior use from the 61511 versus the prior in use from the 61508. They both have the same principle. They both require quality feedback data or failure data from an installed base. Either it is the end user or the operating company, which will be called prior use, which is the method which we call the road to H, or it is the proven in use, which is again called the road to H, but then it's coming from the 61508. However, if you don't have quality failure feedback data available, there's only one solution left, and then we have to refer back to the road 1H, which is the initial total of the standard of the edition 1 of the 61508, which was the one from the 1997 release from the 61508. Further down here in the webinar, I will have been using a method reference where we will call the prior use preference the road to H. We're going to call this the method number 3. That's where the asterisk is referring to my personal definition. And if I go back to road 1H, we will call this the method 1. So there will be 3 possible roads if it comes to building a safety loop. So since the release from the edition 2 of the 61511, which is in the States, the 2018 release of the IEC61511, the only way to build a safety loop is using this reference, which is either you will go to method number 1. That means you go back to the manufacturer, you go back to the theory approach where they have made an assessment on the equipment, where they will use this as road 1H, and I call this here method number 1. That is based on the safe failure fraction and on the hardware fault tolerance. But for those of you who have joined us here this early morning, you will know that the safe failure fraction have been under some criticism by the committee from the 61511, and with all respect, I think they have a valid point. There were too many manufacturers with subsystems. Of course, it is not GMI, but others. But there were too many safe failure fractions that were much too highly judged in the way that the quantity of danger undetected failures were very small in their devices. Because if there is a mathematics specialist here in this webinar and you're looking at the formula from safe failure fraction, you may have noticed that if you can increase your contribution of safe failures, it will always neglect the importance of your danger undetected failures. So in other words, there were some manufacturers where they were actually putting a lot of safe failures in their system architecture that they were accounting for safe failure fraction, bringing the percentage of safe failure fraction sky high, where actually it was not reflecting the reality of quality in their system. Therefore, in the edition 2 of the 61511, they said it is time for the end user operating company to collect failure data. But the problem still today, and we are 2022, is that after all these years, even though edition 2 is out in 2016, 2017, back here in Europe, even still today, there are not many end users who are doing the effort to collect good quality feedback data from their own installations with their own experience based on their own proof test intervals, proof test coverage, etc. Many people still tend to believe that they can use their quality feedback data based on a database that they actually somewhere have purchased from the market and based on some failure data that is maybe not reflecting their experience on their behavior of their safety loops. So coming back on quality failure feedback, method number 2, which is this road to H, which is also known in edition 2 of the 61508, which is quality proven and used, that is for failure feedback data collected by the manufacturers. Question is, how many manufacturers are receiving back some feedback from installation or equipment that has maybe failed, where the end user didn't put the effort in to explain or actually told back to the manufacturer what went wrong with that equipment. And the last method, which is still valid today, is method number 3, which is quality failure feedback data from the end users or operating companies itself. Now, a classical example that some of you may understand, what is the problem here with end users typically is that maybe they have a lack of, let's say, people awareness on how to do this collection of this feedback data, or they may not have the budget to do the root cause analysis if something goes wrong, because they always have the pressure from the operating, let's say, from the process production people to keep the production running. So they may not have the time to analyze what actually went wrong. What I typically ask when I'm standing in front of classes is that how many of end users have you known or met that will actually have a good view on the mission times and on the useful life of their final elements of shutdown valves that actually will replace a valve even before it will fail. In other words, if I see what an end user is still doing today, they will all claim a SIL level, and they will all say they do kind of some testing on their final elements. And if I then ask him, when did you replace this last final element? Its typically answer is when it is broken, when it is not moving anymore. And then you have to ask yourself the question, does it really make sense to predict the PFD, a availability number on such type of elements, when you will not take any care of useful life or mission time on those final elements? Anyhow, we cannot solve this here, but just makes you thinking. So when it comes to the SIL level and the hardware fault tolerance, and the hardware fault tolerance is still a topic here for today. Well, here you see on the right column here, you see the 0, you see the 1, and you see the 2. That means that this 0 here can be built with a single device, a single 1 out of 1 from sensor all the way to final element for any SIL 1 loop, providing that you can prove either the prior use or the proven in use. That means that table 6, which is still called the same table as in the edition 1 of 2004 of the 61511, but we moved on, we are now in the edition 2. Table 6 in the 61511, which is here referred into 11.4.5 in the normative section 1 of 2016 release of the 61511. Well, that table 6 is simplified, and table 6 is saying for any SIL 1, you can build it with its HFT equal to 0. For any SIL 2, which is in a low demand mode, that means where your safety instrument function will not be demanded more than once per year, you can still use an HFT equal to 0. But for a SIL 2, which you go to a high demand, that means your safety function is demanded more than once per year, or you are in continuous mode in your safety function, then you always have to build a minimum redundant 1 out of 2 system into your safety loop configuration. For any SIL 3 that you may have out there, it's always a redundant HFT1. And if you would decide to go for a SIL 4, which is recommended not to use, then you would go into an HFT equal to 2. That means you will have to have a minimum, a 1 out of 3 into your configuration, or a 2 out of 4. Right, Mauro, we have the first poll question to see how many attention did we generated in the previous slides. The question sounds like, when you are looking in the article constraint table 6 as per the 61511, and only one answer is here the most complete and the most correct answer. So that's a little bit like we are doing our exams on the competency reviews. Answer A, can use either this method 1 or 2 or 3, but only one method per safety element function should be used. Answer B, can use method 2 and method 3, both based on road to H mixed per safety as amended function. Answer C, can use only road 1H when claiming prior use for the 61511. And answer D, you can mix per SIF method 1, 2, or method 3 per SIF, all as applicable. Which one do you believe is the most correct and the most complete answer here?
Okay, let's give some time to answer. I see.
Yeah, we need some more interaction. Eh? We have a minimum threshold of clicks that we need to see. Otherwise, I will go and strike. Because it's a moment of strikes again in all the airports here in Europe. So we are getting used to the word strike again. Before it was Corona, now it's the new word is now striking.
Please provide a few more clicks so that we can close and share the results.
They are coming in?
Yes, yes.
And unfortunately, they're not looking very good, but that is maybe the reason why we have to do such a simple webinar once in a while.
Okay, I think we have, I don't know, things are moving.
They're still coming in, they're still clicking.
Yes.
We have a very good participation today, so that always pleases me. All right, Maro, I think we can stop and we can share the results.
Yeah. We are almost to 100%. Okay, I stop it.
Yeah.
And I share the results so that you can comment with that.
Yeah, well, the comment is actually, it's a bit sad because I see that the majority is clicking on answer A, that you can use either method 1 or 2 or 3, but only one method can be used per SIF function. Well, that would be great if this would be true or possible. Unfortunately, that is not real. You cannot easily find only method 1 or only method 2 or only method 3. Because look at any projects that you have been doing so far or have been involved in, you mainly have used the safety PLC, and the majority of all the safety PLC vendors will be on road 1H. The majority of all the material of GMI International is also on road 1H, but there are many different subsystems that you have been using, which are certainly not on road 1H. So it would be great if A would be possible, but I can tell you that is not correct. The only correct answer that I was after here is the last one, is answer D, because we are mixing all as applicable and as available. There are many projects that I see today which are using a mix. Majority is all method number 2. It's all becoming, method number 3. It's all becoming prior use from some install based, from final elements, or let's say from installations that end users are using, together with a safety PLC and some material from GM International that is on road 1H. And sometimes we see more and more now that there are vendors going to road 2H, and road 2H meaning the proven in use. So it is method 1, 2, and 3 all as applicable. And I will try to explain that more on the next slides. So I made here a summary, which is a summary which gives you 2 tables. And there are 2 different tables in here. I mean, the table which is on the left-hand side is your hardware fault tolerance. That hasn't changed. So here you see an HFT 0, 1, and 2, which are the main configurations that you will have to deal with in the future. And if you are only after safety, look in the middle column, which is your architecture for safety availability. That means that if HFT 0 is being required, you can build that with a 1 out of 1. But it also means clearly that there will be no safety availability, because if one danger failure will be in your installation, you cannot achieve safety anymore. If you have to have an HFT of 1, that means you need to be able to tolerate 1 danger failure. Then as a minimum, you will install a 1 out of 2. And if you have a HFT of 2 requirement, well, then you will have to install as a minimum a 1 out of 3. However, Production people, they will more focus here on the right column, and the right column is the architecture for production availability. And if you actually look here for production availability, and you have here an HFT of 0, that means you can achieve an HFT of 0 with a 2 out of 2. But that would mean that with a 2 out of 2, you can tolerate one spurious strip and still keep your production running. But that doesn't mean it will be safe, because here you cannot tolerate any danger failure. So if you are an HFT of 1 over here, and you look for safety availability, and you also want to have some production availability, that is where you will select a 2 out of 3, because you can simultaneously, you can tolerate one danger failure, and you can tolerate one spurious strip. And if you want to have the best of both, you can tolerate 2 danger failures, and you can tolerate 2 spurious strips. That is where you would have to select here a 2 out of 4. And how do you read this table here? The architecture is always in standard being explained in a M out of N. The first M stands for your independent voting channels, and the last N stands for your redundant channels. That means that will explain you how many independent voting, in this case here, 1 independent vote out of 3 redundant channels needs to be available, enabled to execute your safety function. I summarize this here with 2 examples that is coming out also from our training course. The left-hand side, if I look here, I got a reactor, I got an inlet of a reactor, and I got 2 valves. The 2 valves are being configured in a 1 out of 2. So I'm using 2 fail to close valves. So I'm able to isolate the inlet to my reactor. I can either close valve number 1 or I can close valve number 2, but I have to be able to close either one of them. That is great for safety. Assume that the second valve over here is stuck open, but I can still close the first valve over here. I can still isolate, I can still bring this reactor into a safe position. So that's a great story for the safety people. That's the worst solution for the production and for the operator people, because here, if one valve is closing for no reason, you will actually lose the production, and they may not be happy with you, because when one valve has a spurious strip, you will lose here your production. So the left-hand side is a great solution for safety availability. It's the worst solution for production availability. Opposite, I got here the reactor, the same reactor, but now we're looking at the drain function. And we want to be able to protect the production inside my reactor. That means the drain function will not be done with 1 valve, but we will install a second valve. And both valves are now in a fail open configuration. That means we have to open the valve, enable to drain, meaning that if one valve would spuriously starts to leak or go open, I will not lose my production content. It means that that's the great solution. However, for a safety engineer, that is the worst installation you can have for safety availability, because if one valve is stuck close, you may open this valve, you may never be able to drain. So with this example here, on the left-hand side, you can clearly see with a 1 out of 2, we will actually enhance here our safety availability, because either one of them may be failing to close and I can still close the other one. That's great story for safety, but that's the worst solution for the production availability, because if the valve is leaving there or leading their own life and one valve is closing for no reason, you may lose your production. On the right-hand side, opposite story, that's the worst solution for safety, because only one single valve stuck close and you may never be able to drain anymore. But that's a great solution for production availability, because if one of those valves is starting to leak or is opening spuriously, then you may not lose your reactor content. This is the final slide as a summary, and that's a summary that may help you in the future on how to make your hardware fault tolerance selection based on method 1, 2, or 3, which is called method 1 and 2, is based on the IEC61508 edition 2. And road 1H here, that is based on the theory approach. That means that here, the theory approach will be that the vendor will do a failure mode and effect analysis. They will actually define what is the safe failure fraction. They also have to define what is the systematic capability of such a subsystem. It will be distinguished, either it will be type A or it will be a type B. They also will have to provide you with a safety manual, meaning that any compliant IEC61508 subsystem shall have a safety manual with all this data and information being explained for you in there. It may also have a certificate and a report, but that's not normative or mandatory required by the standard. That is purely as a, let's say, a kind of a marketing and a competition between the vendors, but not required from the standard. The standard only requires a safety manual, and also they will require a PFD/a PFH, depending on which type of subsystem that you are using. So summary, if you are selecting row 1H subsystems, based on the safe failure fraction table type A, table 2, or table 3 type B will tell you how many HFT you will need to achieve your SIL level. And if you go to the quality field feedback, that means that if you go to row 2H of the IEC61508, that means that the manufacturers will have to prove from similar application environments some quality feedback data, and there will be a confidence level in there of more than 90% as a minimum required from the standard. They will have to collect the data based on those two standards, which are kind of quality collection standards. If you go to the last option, which is the preference for the IEC61511 standard, then it will be row 2H based on the end user feedback, guidance for the, let's say, giving in the report 4 of the 8404, which is the, it's still showing here 2015. In the meantime, there is a new edition out, which is the 2020 by memory. So that should be here reading 2020. I have no idea why they're still showing here the old reference, but in the standard today, the 2016 edition 2, they were referring to 2015. So I probably took it out of the standard. The other conditions will be that full variable language and limited variable language needs to have a diagnostic coverage of more than 60%. Here you have to have a confidence factor of more than 70%, plus you have to prove performance evidence in similar operating environments. The problem will be who will have quality failure feedback data to comply to row 2H, either in the method number 2 or in the method number 3. Right, we have one more poll question, and then we go to the Q&A section received during the registration.
Yes,
so
I'm
the
sharing.
Question is,
yeah. Sorry.
It's okay, Maro, no problem. The question is here to make a difference between safety availability versus production availability. And again, only one answer will be here the most complete and the most correct answer. And the first question is a 1 out of 2 and a 2 out of 3 are the same for production availability. That is your first selection you can make. The second selection is a 1 out of 2 is better for safety availability than a 2 out of 3. Question number C is a 2 out of 3 provides both safety and production availability. Answer number D is a 2 out of 2 and a 2 out of 3 provide the same safety and the same production availability. And the last question is here a 2 out of 2, 2 out of 3, 2 out of 4. All architectures provide the maximum safety and the maximum production availability. Right, again, the same story. You need to have some interaction going here. So only one is the most complete and the most correct answer.
Let's give some time to digest the question.
And we expect at least the same contribution as with the previous poll, which was quite good. So we leave them a few more clicks. There are no prizes to win.
A few seconds again, and then I will stop and share.
This is a classical game for engineers. Or engineers.
One click more, please. Okay, good. So I stop it.
Yeah.
Very high rate today. And
very good. Well, thank you for the contribution. Well, the good news is here that the one that has the majority of the votes here is actually the correct one. A 2 out of 3 provides both safety and production availability. That is the one that we were trying to explain. And there's also the one that I actually mentioned in the summary, where a 2 out of 3 can simultaneously tolerate one danger failure and still keep your plant safe, and can also simultaneously have one spare strip and still keep your plant running. And that is actually quite a neat feature. That is also why many of your sensors most likely will be configured in a 2 out of 3. Would be great if your final elements would be able to go for 2 out of 3, but unfortunately, that is not so easy to solve in reality. So the other ones that were selected here, there were a few items which were, of course, the trick in here, like 1 out of 2 is better than for safety availability than 2 out of 3. No, because they are the same. That is the reason why answer B was not correct. Answer D, a 2 out of 2 and a 2 out of 3 provide the same safety and production availability. That's also not correct. They both have the same spare strip that they can tolerate, but the difference is that a 2 out of 2 cannot tolerate any danger failure. And the last one is the same story again, 2 out of 2, 2 out of 3, 2 out of 4. They are all the same from spare strip point of view. That means they can both tolerate, or all can tolerate one spare strip. The only difference is that a 2 out of 2 cannot tolerate any danger failure. So HFT in this particular case is here 0. All right, Mauro, I will stop sharing and we will conclude and go to the Q&A. Oops. So, as Mauro was saying, besides training, we also provide some services. These are all the lifecycle services on SIG1511 and also on the 62443, which is the OT security standard that we are using in the edition 2 of the standard SIG1511. You are asked, you shall carry out a security risk assessment of your plant. So many end users, of course, are not having the necessary awareness yet. That's also why, besides the services, we also provide the training. And as Mauro was saying, we are currently in 2022, I have been doing for the moment 60% of the training is all face-to-face again, which I'm happy to say that I do prefer the face-to-face versus the virtual. Virtual have also some benefits in other parts of the world, but we do provide still today both virtual and classroom instructor-led trainings. My main occupation still today is doing the functional safety engineer CIS competency review together with TUV Rhineland. We also provide the cybersecurity fundamental course and the security risk assessment, which are all the courses here that you see. The first 3 bullets are all 3.5-day course. Basically, there are 3 days instructor-led trainings, and on the last day, you will have a closed book exam. We also do customized in-house trainings, webinars, seminars, etc. Plus, that's the best book on the market. That's the book that is more than 50,000 copies worldwide, provided by GM International, which in chapter 7 and 8, I have been writing the executive summary on SIG1511 in chapter 7. And on chapter 8, I have been giving one safety implement function example with 29 items that shall be described and shall be included as per the SIG1511 edition number 2. Right, I will close this here and I will stop sharing this. And Mauro, do I open the Q&A?
Yes, please. Yes, please.
Let me share the Q&A quickly, which should be hopefully.
All right, if you want, I can.
That's okay. I've got it here. I'm ready. Q&A. All right.
Yeah, as Tino mentioned, we have collected during the registration phase a few questions. Actually, we have 3 questions which Tino will answer. I want just to remind that you all still have the chance, if you have any additional question, to make use of the question and answer box. So I will monitor that. If you have a specific question, if any of the subject was not clear for you, you can have the chance to raise a question, and Tino will answer. Until this is coming, any question is coming, we can go through the 3 questions we collected.
Okay, so there was a question in the registration: minimum architectural constraint in SIL verification ? And I was looking at this question and I was focusing on specifically what does SIL verification have to do with the minimum architectural constraint requirements. So the minimum architectural constraint, as we just have seen in the webinar, needs to follow the level of SIL based on the table 6 that you claim on road to H, prior use or proven in use. Okay, so prior use or proven in use, and or the table 2 and 3 as of the road 1H. So the minimum architectural constraint, I don't want to discuss this here again. HFT will of course influence your safety availability calculation, because when I'm talking about SIL verification, I do assume that the participant who was asking this question is thinking about how can he or she verify the reliability or the availability of that safety loop. And of course, if you have a different configuration, it will also influence your SIL verification calculation on that particular safety loop. I'm getting an additional question, Mauro. Should I read it quickly?
Yes, I think I will answer.
Okay. All right. So I got a question coming in. I got you can provide support training for FS registration. Anyway,
regarding, I think it is
functional
regarding
safety regarding. Yes, sorry. You see, all this abbreviation that we engineers are using is just to trick sometimes our mind. So I read the question again. I got you can provide support training for functional safety regarding IEC61508, 61511. What about safety in the railway sector regarding SINELEC 50128? Unfortunately, I cannot provide it myself, but I do have a trainer working together with me that can help you to provide you with that type of specific SINELEC railway functional safety standard. Okay, Mauro, let's move on. So, we answered this live, so this is done. The proper architecture definition and selection of the right elements is getting more and more important since the proposal stage of complex plant. Okay, so when I read this question, it was clearly coming from a participant that is working for a EPC contractor. And I can assume that if you are in the proposal stage, that means you need to make a quotation somewhere to build a complex, let's say, solution or a complex plant. Well, of course, the architecture definition may, of course, influence the budget. So I can imagine that this is quite a challenge in the proposal stage to make some definition what type of architecture, which is sometimes not even possible. So when I answered this here, I said the problem is often that the detailed requirements during proposal stage are not known yet. I can imagine that if you have to propose a kind of a solution to a client, that you may not know yet how you will solve that end of the day to achieve a certain SIL level. And it's typically the SIL level that is actually driving some of those decisions, because only a SIL number estimate will not define your architecture, as different solutions are potentially possible. Because end of the day, depending on what type of subsystems are available on the market, what type of systematic capability can you find on this type of subsystems, will define, do I need one subsystem, two subsystems, or even more? Even more to the point, the road 1 solution versus the road 2 solutions may again give you some different hardware fault tolerance, some different architectures end of the day. More and more mixed solutions are being used. That was also one of the poll questions, where we said that road 1H together with road 2H are very, let's say, very typically mixed today, where your safety PLC, as an example, will be road 1H. maybe your field sensor, maybe road to H, maybe your barrier from GM International will be also road 1H. The safety relay from GM International will also be road 1H, but maybe your solenoid, or maybe your final element, maybe road 2H, or maybe you have nothing there. So how will you mix all those together? That is where your challenge will be on defining what is your hardware fault tolerance. The final solution achieved is unfortunately sometimes limited to the budget available for the project. And that's often what we see, that sometimes proposals made and sometimes proposals that are being selected by the procurement departments are not always the maximum solutions that you want to have on site. That means that sometimes you are being driven by some budget constraints or restrictions. And therefore, that is often what we see, that people will be forced to use end of the day. I got a second question coming in. Does it exist a silk calculation tool using road 2H? Well, the question is actually a bit of a tricky question. I can answer it in different ways, but I will try to answer it as fair as possible. If you say road 2H, you probably mean prior use from the end user or operating company. That means the end user, besides prior use, also will have to have some failure data, some frequencies of those failures. And if those frequencies, of course, are accurate, you can actually calculate with those frequencies the same as you could do with a road 1H frequency. Second answer that I can give to this, if you would mean the frequency is given by a manufacturer on road 2H proven in use, then here the same answer, yes, you can use also those frequencies. So summary, I can use road 1H or road 2H frequencies, providing the frequencies are accurate. I can use them in a silk calculation to predict the reliability of that safety loop. Okay. The other question that I collected, when we need to use IEC 61511 and IEC 61508 based on the project scope. Well, here the end user operating company projects for the process industry will first, as a preference, try to use the 61511 table 6, which is the road 2H, the prior use. However, many subsystems that you will find on the market will be based on manufacturer-specific functional safety standards, which is the 61508, which is the road 1H, or sometimes the road 2H, from the proven in use from the 61508 itself. End of the day, all projects will mix both road 1H and road 2H, as we mentioned already before, based on the availability of the type of subsystems. The good news is that the minimum HFT 0 and the minimum HFT 1 or the minimum HFT of 2 remains the same, regardless if you select end of the day road 1H or road 2H. And that's it. We have the last poll question for Mauro.
Yes,
to
we have the very last question for all of you before to close the webinar today.
I think, Mauro, I should be selected with an award. It's probably the first webinar in history that I actually finished on time for you.
Yes, that's true. 1 minute before, just the time to the last question.
So maybe I'm getting proven in use now in doing webinars.
Yes, true. I take the time while the people are answering. Just to remind that you will receive copy of the slides, as well to inform that this webinar have been recorded and you will find it soon on our GMI web YouTube channel. Sorry. And a recommendation to monitor our GMI website, because we are always providing different kind of trainings, as said, functional safety, different topics we have. We will have new topics soon, but also we cover intrinsic safety and other application. We are doing other application webinars. So you just monitor the website and you will see, I'm sure you will find other kind of topics that you believe will be useful for you. So I think we have almost received something like 100% of the click back on this, and the result sounds very, very good. So thank you very much, Tino, for this hour dedicated to us, and thanks to all participants. And of course, we look forward to meet you again. Again, in the presentation, you will see also the contacts. So if you have any questions or if you have any doubt, you can get in touch with us again.
All right. Thank you. Thank you, everyone. And thank you, Mauro. Let's stop sharing this here.
Yeah.